Billions of new wireless devices are brought online each year, and this number is only going to exponentially keep growing. But the underlying resource that makes all of this possible, the radio frequency spectrum, is still managed in fundamentally the same way that it was decades ago. It's bought by and sold to the biggest players at multi-million-dollar auctions, like pieces of old farm equipment, making it very hard for there to be real competition and innovation, and leaving the people who want to do this fighting for the scraps. This resource is finite and a key to the future of human connectivity and things like freedom of speech, and it needs to be managed better. This is what we're aiming to do at Fosa, and what we're releasing today is going to lay the groundwork for us to do this in the future. But first, let's talk about our existing software tool. Earlier, we had released a wideband scanning tool for, initially, our software-defined radio, the SDR stick. This allows people with low-cost software-defined radios to perform wideband scans and get a better picture of what's going on in the radio frequency spectrum around them. But this tool has outgrown that initial case. We've already added support for the HackRF, and we're going to continue to add support for new radios in the future. We're building this out to be a fully fledged signals intelligence and software-defined radio platform, open source, and for you guys. So because it's outgrown this scope, we're renaming it to Raven. It's still going to be 100% open source and MIT licensed, so you can take the code and do whatever you want with it. We've added a few new features that we'll talk about later, but a fundamental issue still existed: the ability to get data in and push data back out. And this is what we're releasing. We're calling it Olympus. And fundamentally, what this is going to be is a platform to aggregate RF data and do analytics and processing on that data to redistribute it and make access to spectrum data at scale easy, cheap, and available. The idea is simple. Users will host a software-defined radio that aggregates data from the spectrum and rewards the user for providing that coverage. The data comes into our backend, where we do processing and use machine learning to extract analytics from that data and provide it to not only industry customers, but regulators and back to end users as well. Because the more we know about this fundamental resource, the better we can manage it, and the brighter the future will be. Right now, Olympus is available as a beta, as a subscription on our site. This is initially just meant to be used as a side-by-side tool with Raven for signals intelligence purposes. It currently offers API access to our radio reference database, and we're working on expanding the backend for what we have access to there. So when you're doing your wideband scan, you can get systems that are cataloged in a variety of different databases and get information instantly about what frequencies are active and what systems might be using them. It also currently has a signal identification database that we're working on growing out and expanding, so that if you see an unknown signal, you can click on it and get a list of different types of pre-recorded signals that have been known to operate in that frequency range and get an idea of what that signal potentially might be. The other thing that Olympus currently offers is the ability for you to take your scans and upload them to the backend. The initial thing that we're going to provide very soon is the ability for you to, once you've uploaded your scan, get back a list of all active frequencies for that scan and associated systems for those frequencies. This allows you to really get a picture of what's going on in the RF spectrum, not just by looking at the spectrum activity or the cataloged systems, but really combining them and getting a fuller picture of what's going on. This will also allow you to get a list of open and available frequencies, which is fantastic for doing frequency planning or planning repeater inputs and outputs if you're setting up your own small-scale infrastructure, so that you can be confident that you won't be interfering with other signals, or that other signals won't be interfering with you regardless if the system is cataloged in a database or not. We're going to be rapidly expanding the capabilities of Olympus to reach the stated goal of easy to access spectrum data. And we hope that you join us in building this. Raven will always be open source and MIT licensed, so you can take the code and do with it what you want. And we hope that you build with us as we move forward towards this mission, because the future can be good if we make it so.